So today we're going to start chapter 6 and we're going to expand on our idea of probability. So in chapter 5 we studied probabilities of random events and we saw that probabilities can be unpredictable. However, if we watch enough random events, patterns begin to emerge. We begin to understand what is common and what is unusual. In this section we're going to introduce a new tool to help us characterize probabilities of random events, which is going to be our probability distribution. So before we get to that, if we look at the title of this section, notice that the title of this section is Probability Distributions are Models of Random Experiments. So the first thing that we're going to define is going to be a probability model. A probability model is a description of how a statistician thinks data are produced. Remember, we use the word model to remind us that our description does not really explain how the data come into existence, but we hope it describes the actual process fairly closely. We can tell if a model is good by noting whether the probabilities that it predicts are matched by real-life outcomes. Right, so our probability models are directly related to our next definitions, which have to do with probability distributions. A probability distribution is represented in different ways based on whether we have discrete outcomes or continuous outcomes. Okay. Both discrete and continuous outcomes they're both types of numerical or quantitative variables. So we are thinking numbers for both of these, right? So they're not categorical, they're numerical. There is a difference, right? So the first type of variable are going to be our discrete outcomes. Discrete outcomes or discrete variables are numerical variables that you can list or count. So the key thing that we're looking at here is that these are things that can be listed or counted. Only whole numbers can be used when measuring discrete variables. Right? Continuous outcomes or continuous variables cannot be listed because they occur over a range. We generally use the rational numbers, which include decimals and fractions. So the idea is here with continuous variables, instead of something that's being listed or counted like our discrete variables, these are something that are being measured. So our values for our continuous variables are values that are being measured rather than counted or listed. Right, so we're going to look at these ideas a little bit in the example on the next page when we are comparing our and looking at this list of different variables and trying to decide if they are discrete or if they are continuous. Right, so identify each of these numerical variables as discrete or continuous. The weight of a sandwich that you are served at a deli. Weight is a common one that we're going to see in some of our examples. Our weight is something that is going to be a continuous variable because our weight is something that is measured. Right? It's not listed, it's not counted, it is something that is being measured. It could have fractions or decimals attached to it. The number of people in the next passing car. The number of people is something that's going to be counted. So this is going to be discrete because the number of people is something that is going to be counted. The number of contacts stored in the phone of a classmate. Just like with B, this is going to be something that is counted. So this would be another example of a discrete variable. Right, and then last but not least for D, the elapsed time between leaving the house and getting to school. Right, elapsed time is something that is measured. Right, oops. So since it is measured, it is a continuous variable. So continuous because it is measured. Right, the idea is here, we could go down to fractions of seconds or fractions of minutes or whatever sort of time you're using. So again, anything that is measured is going to be a continuous variable. Anything that is counted is going to be a discrete